The first thing I'll do, I'll just put always choose 2911 route. I saw you were choosing I don't know.
Yeah, that was the concern. Like, cause I couldn't find out some interfaces cable
Yeah.
because
In
I
this,
was out of it, and I was why.
yeah. So in my configuration, we're just going to use three types of router: 2911. We're going to use 2811, and maybe these two, 4331 and 4322. But at this stage, we're going to use 2911. So okay, so this is the same topology that we're going to use, and I want us to start with the RIP. So I'll just do this. I'll write here RIP. And now what I'm going to do is just to assign the host computer's IP address. Then I'm going to send the router's interface's IP address according to what I've just written here on the interfaces. Although as per now I'm just using this kind of I'm just becoming too much extravagant, between these two networks I should not use /24. /24 basically means that we have around 254 hosts. So I'm just kind of I'm wasting a lot of addresses. But as time goes by, we're going to learn how to use the correct number of IP addresses between two point to point, or between two, between the point to point link. For example, this one and this one. We only need two IP addresses here for this interface and for this interface in this network. But in this network, we have 254, meaning 252 is just wasted like that. So we don't want to waste any IP address starting from the next class. I'm just going to show you how to do it more practically and for the best practice in subnetting. Alright, so let me just configure IP address to the interfaces very fast. Okay, now the IP address to between the routers. So for example, for this interface, it should take 1.1 because you see it's connecting to this LAN. For this interface, it should take 2.1 because you see it's connecting to this LAN. So let me start with the gig 02 on this side, gig 02. I just go to config, then gig 02, and I told you this is not a good practice for a starter. 1.1, and that's okay. Then I go to gig.0, so gig.0, I will turn it on first. Then IP address is 10.10.10.1, and started mask 255.255.0. Then you come to gig.01, gig 01, turn it on first. Then the IP address is 10.10.11.10.11.1. Okay, that's okay. Right, then let's go to this router here. So for this interface, it will take 11.2 because this one take 2 11.1. So this is this interface is gig 00 on this side. This is gig 00. I turn it on. Config gig 00. Turn it on. Alright, then I set it 10.10.11.2 and started mask of 255.255.0. Then I move to gig 01. Gig 01 also 10.10. Now I'll check on this network, which is 12.1. IP that remain that way. Turn it on. Now it's done on this side. Let me go to this side. Gig 00 will take 10.2 because this one took 10.1. Alright, so gig 00 on this side. Gig 00 on that side will take 10.10.10.2 and separate mask of 255.255.0. Turn it on. Then gig 01 should take 10.10.13.1. Gig 01 10.10.13.1. Sorry. Then that one remains that way. Alright. So when we come to here, we can come to this router. Let's first assign this one IP address 2.1 gig 02. So gig 02 should be, sorry, not that one, 12.168.2.1. that's IP address. Then you turn it on. Then we come to gig 00. We should take 13.2. This one should be the 13.0 slash. So gig 00 should take 13.2. Gig 00 should take 13.2. 10.10.13.2. Turn it on, and the IP address should be 255.255.0. Separate mask coming. Then gig 01 should take 12.2. 10. Just a minute. 10.12.2. Turn it on. Then that's okay. So we're done. And now what's just remaining here is just to begin the configuration. So what I'm going to do, I'm just going to use the same diagram to configure all the routing protocol. So the first thing I'm going to do, I'm going to configure RIP. We test our network. Then I'm going to delete RIP in all the routers.
Delete?
Yes. I'm going to show you a command to delete what you've configured. Then again, we're going to configure EIGRP in the same diagram. Test and ensure everything is working. Then we delete EIGRP. And finally, we're going to configure OSPF, test, and we verify if it's working. Then we end there. So let's begin with RIP. Let me take water. And come tomorrow. So, like I said, are you there?
Yes.
Yeah. For this network on the left side, to communicate with the network on the right side, then all of these routers should know that this network is there, this network is there, all of these routers. So we began with configuring static routing, of which we did. And now we're in a dynamic routing protocol. We started with RIP. So let's configure RIP to advertise all the networks. So what we do here, we go to each router and advertise only the directly connected networks. So for example, in this router here, we go to advertise how many networks? 3. This network, and this network. Only the directly connected networks. On this router, we only advertise how many networks? 2. This one and this one. Same apply to this router. But for router this one and router 0 here and router 2 here, we advertise 3 networks because you can see they are connected using 3 interfaces. This one, and this one. So let's begin with this router here. I'll click on it. Exit. The first thing that you do, you have to make the router aware that it's using a particular routing protocol.
I don't know. Can you scroll up a little bit because I get lost at some point.
Oh, where?
No, I was like needing to check the command that you started with.
No,
But
I didn't.
scroll up.
I've not configured anything. Just IP addresses.
Yeah.
Yeah, I've not started configuring RIP. I was just explaining how RIP works. Where did you hear me last?
From when you were about to start, like configuring.
Okay, I'll repeat what I was explaining. So in this topology here, for this network here, to communicate with this network on the right side, then all of these routers here must be aware that this network is there, this network is there, so that they can easily pass information to the destination. So whenever we are configuring RIP, whenever we are configuring RIP, we have to advertise only the directly connected networks. So for example, when you go to router 0, this is router 0. The directly connected networks are 3. This network, because you see it's connected to this router, this network also is connected to this router, and this network is also connected to this router. We advertise 3 networks on router 2, on router 0 and router 2, because you can see they have 3 connected interfaces. But for router 1 and router 0, they only have 2 connected interfaces, meaning we are only advertising 2 networks. But we have to go to each router and advertise the directly connected networks. Because this is a dynamic routing protocol. Whenever we just advertise the directly connected networks, they will exchange information and let each other know the status of the other guy. So let's start with RIP. I click on RIP. I click on any router, and I was just issuing this command because we were configuring IP address. So this was just a configuration of IP address that we did before. Although you know, when you configure IP address on the GUI, it also display on the command line. So there's no big deal there. So how do we configure RIP? The first thing that you do, you make the router aware that it's using that particular routing protocol. So you click on that router and you just say router RIP and you hit enter. Then very importantly, in RIP, you know, you have to specify the version of RIP that you're using. You just issue command version and use version 2 and you hit enter. Now you advertise the networks. We have 192, 168.
And the version, where comes do we use only version 2?
Sorry?
Do we use only version 2?
There's version 1 and version 2, but you know, whenever there's version 2, meaning version 2 is better than version 1. Yeah. So you can use version 1, which is not recommended because, you know, whenever there's any update, meaning the previous version had problems. So it's recommended because there are only three versions. Version 1, version 2, and there's a RIP next generation, which is yet to be developed. The third version is yet to be developed, so it's not usable here. You only use version 1 and version 2, but in every case, make sure you use version 2 because version 2 is the best one because, you know, whenever there's any updates, you move to the upper version, meaning the previous version had problems. That's why version 2 is there. So make sure you specify version 2 here. First command, make the router where it's using RIP. Second command, specify the version of RIP that you're using. Make the router where it's using version 2. Now it's a time to advertise your network. Go back to that router and check on that router. That router is connected through 3 interfaces. 1, 2, 3. So take the first interface and check the network. The network is 192.168.1.0. You just come here and we just say network 192.168.1.0, and that's all. You just hit enter. You come again here. This is the second interface. 10.10.10.0, then 10.10.10.10.11.0. I just come here again and just say network 10.10.10.0. You hit enter. Another one was 10.10.11 and you hit enter. And finally, there's something that we call auto summarization. You know, in RIP, we don't want it to summarize routes. You know, when the routes are summarized, it's like you are just having one long entry of IP address instead of few, you know, instead of a grouped, how can I say this? Instead of subnets, something like that. Whenever you group them is you subdivide them. So, you know, when you subdivide something, it's easier to manage and it's easier to see. But when you just mix them there, it's very hard to look upon it and check where it is and manage it. That's why we tell a route, don't summarize those routes, because whenever you summarize them, it will take time to look where the routes are and see them and apply them. But when you don't summarize them, let's say they're just there the way we configure them, it's easier to find them and to use them. So we just issue command no auto summary, and that's all about RIP. First command, make the router where it's using RIP. Second command, make the router aware that it's using version 2 of the RIP. Then advertise your networks. After advertising your network, tell the router to not summarize these networks into one network, because if it summarizes all these networks into one network, it will really take time to look where our network was and to apply it. So after that one, we just say do right, and we're just done with that router. We move to this router. Let's move to router 1. Come to CLI, enable config T. The first thing you do, make the router aware that is using RIP as the routing protocol. Then the version of RIP, version 2. Then now you advertise the network. You advertise this one and this one, the directly connected network. You don't need to advertise any network other than the directly connected networks. So it's 10.10.10, 10.10, 11.0 and 10.10, 12.0. So I'll just go here and say network 10.10.11.0. Just hit enter. Another network is 12.0. After doing that, tell the router, do not summarize these networks into one network. No auto summary. And do hit enter, exit, and do right. So I go to this router also and do the same. So the first thing, make the router where it's using RIP. Then the version of RIP, version 2. Then come back to the topology and identify networks. So I can see 10.10.10 and 10.10.13. So I just say network 10.10.10.0 and 10.10.13. That's all. Then tell the router, do not auto summarize these networks into one network. Exit, do right. Finally, let's go back to this router and advertise the networks. Enable config T. Make the router, the first thing, always make the router so it's using RIP. Then version of RIP.
Version 2.
Yes, version 2. Then you go back to topology. Yes.
Topology. So
we have 30, 10, 10, 13, 10, 10, 12, and this one also, because you can see it's connected to using 3 interfaces.
Yeah.
So just network 10.10.
No, you start with that one or not? I thought you have to
no problem. You can start with any. Yeah.
Okay.
.2.0, hit enter. Then another one, network 10.10.12.0. Then the other one was 13.0. No auto summary. Exit and do right. So basically we've configured RIP in this topology, and this device here can be able to communicate with any device in the network, any of them, because all of these routers have known the status of each other. They've known the status of each neighbor, so they have become friends. They have exchanged information, and they can let each every host in the network communicate. So I'll just try to ping from this PC to this PC or this PC. So I'll try to ping 192.168.2.10. So we just have to give it some time. So you see it's reaching, and then to 2.20. So it's also reaching. How do we verify RIP? Let me go to this router and do show route RIP. I just want to test if there's any command to verify RIP. Show IP RIP. Okay, show IP RIP database. So whenever I type that command here, whenever I type show IP RIP database, you are going to see all of this network. You are going to see 1.0, 10.10.10, 10.10, 11.0, 10.10 and 13, 10.10, 12, no, and this one. So let's start. 1 dot something is here, and 2 dot something is also there on router 0, and router 0 is on this side. So it has known that there are other networks in the topology. And also let's come to 10, 10, 10. You can see all the 10, 10, 10s are here. And you can also go to this router also to test and show IP RIP database here. And you will see all the networks here in this router, meaning that all of these routers, they have changed their information. They have let each other know their status. So 2 and 1 are here, and now we come to 10, 10, and all the 10s are here. So that's how to configure RIP in your topology. It's very, very simple. We just go to that router. The first thing you do, make the router where it's using the RIP as the routing protocol, then specify the version of RIP. Then come back to your topology and check clearly that carefully how many networks are connected to that router that you want to configure RIP. Then advertise those networks using this command network and specify that network. In RIP, we don't use subnet mask, but from EIGRP, we're going to learn how to use subnet mask. Okay, then you specify no to summary. And that's all about RIP. Maybe if you can have any question and we check, because RIP is the simplest one that I have ever encountered in my career life. Do you get any question?
So for these, there is no need to go through like a first configuration, the host name or whatever. You simply do router P version and the network.
Yeah. So
no summary. That's it.
well, on those are just basic configuration. Basic configuration that do not affect other configuration.
Okay.
Yeah, they don't affect any configuration. You can do this and do that. Yeah, okay. You can do any that you like. You can even configure them together, or you do one. But it depends on the question that you given. Okay. So, as I promised earlier, we are going to use the same diagram to configure EIGRP. So I'll change here to EIGRP. Now, what am I going to do? I'm going to delete RIP because we don't want to have a situation where you have two dynamic routing protocol in the same router. We just go to any router, config T, and say no router RIP. Remember, this is the command that we are using to tell the router use this routing protocol. Now we are telling the router do not use it, and we use center, and we say do write and reload. Do reload. So we're telling the router do not use RIP in this case. Then we are saving the configuration and we are reloading the router to take the effect without RIP. Yes. So same thing, you go here and you tell that config and say no router RIP. Sorry. Do right. Do reload. Reload the router. We go to this one. Say no router RIP. Do right. Do reload. And finally, we go to this this. Just say no router RIP. Do right. Do reload. Okay. So if I just go here and just say enable config T and just say exit and just show IP RIP database. So we can see there's nothing coming. There's nothing coming because I've deleted all the RIP configuration on the router. That's
the command is no IP router, no router RIP.
Yes.
Then do right. Then do reload.
Do reload. Reload. Yes. So we know when we are configuring RIP, we were telling the router, just even in this case, well, is it okay? So when we were configuring RIP, we were telling the router use use RIP as the routing protocol, and now and now we are telling the router do not use RIP, no router RIP. So the router will remove all the RIP configuration from its database. Alright, so let's begin configuring EIGRP. Just the same way we have explained the concept of RIP. Whenever this network wants to communicate with this network, there must be a routing protocol to tell all these routers that you need to advertise this network, and this network, or to let each other know the status of one another. Okay. So how do we configure EIGRP? Just configure T. Same way, just make the router aware that it's using EIGRP. But now here we group them in terms of autonomous system number. Let's say number 10. Let's say number 10. Remember, in RIP, we were not grouping anything. But in EIGRP, we have to group them because there's a concept of autonomous system number. So that's why we put here router EIGRP 10 autonomous system. This represents autonomous system number. You can put anything, grouping, and you hit enter. Then that's all. You don't specify the version. In EIGRP, we don't use version. We just go directly to the router and advertise the network. So we're going to advertise this network, and this network. Click them and just say network 192.168.1.0. And now in EIGRP, we use subnet mask. Subnet mask here was /24 notation. /24 notation is equivalent to just each space, then 255, 192.255.255.0. There's a concept of wildcard mask. There's something called wildcard mask. Wildcard mask basically means the inverse of subnet mask. So in this case, I'm not going to use wildcard mask because you don't know how to calculate it. I'm going to show you how to calculate a wildcard mask so that in the next project that we're going to do, or in the next classes, we'll start using wildcard mask, which is the most recommended method of using it. So I just hit enter. Then another network is this network with the /24, 10, /24. Another network is 10, 11, /24. So I just go here and I just change this to 10, 10, and to 10, and I hit enter. And I also change this to 11. I change this to 11. And that's all about EIGRP. That's all about configuring EIGRP. We just exit. Let me just query if there's something, or to summary, or no need here. Distance, no need. Exit. Okay. Neighbor, no need. Network, no need. No need. So just hit exit. So EIGRP is all of these are simple. All of these routing protocols are very simple, except static routing, which is very cumbersome and time confusing for consuming. I mean, so in EIGRP, just make the router that it's using EIGRP with the autonomous system number of 10, the grouping system. Then you just advertise.
Who determine the grouping system? Is you or it's given in
I can't hear you.
How do you determine the grouping?
No. You just
In the number 20, is it given?
No. You just use a random number. You just use a random number. You don't have to. There's no determinant here. You just use a random number. You can even use 2. You can even use 3 or 1000.
Okay.
Yeah. So, for example, if you just meet a bunch of students and you want to group them, a group of 10, you just say, I'm giving a group number 17. There's no criteria, you just randomly do the it. Yeah. So, our autonomous system is just something random that you just do it, but make sure it's a number. As per this case, just make sure it's a number between 1 to 100. In this case, because I've never seen someone grouping more than 100. Yeah. So it's done. So I'll just do right here. Go to this router and advertise this one and this one. Click. Just a minute. Let me just make some guys who are waiting for me to give me some 30 minutes.
Okay.
I have another meeting in the next that I should be having it from now, but I'll postpone it till okay. So same way we go to this router, advertise this network and this network. I just go to this router and I say enable config T and make the router aware that it's using EIGRP with the autonomous system number of 10. I was saying that in this topology, you have to make sure that these students are in the same group. Don't make this student group 8 and this one group 10. they will not understand each other because they have let's say class 1 and class 8, they have different levels of intelligence, so they won't understand each other. So router EIGRP 10, then we just go to advertise the network 10.10.10, sorry, .11, I believe so, .0, then the subnet mask 2555.255.255.0. Hit enter. You can see EIGRP 10 has found new adjacency. Adjacency is like a new neighbor. So the neighbor is the other guy, which is that one. 10, 10, 10, 11, 10, 10, 10, 10, 10, 11.1, which was IP address of this interface. If I move over it, you will see 10, 10, 11.1 is there on router 0. So router 1.0 have become friends. So let's advertise another network, which is this is 12. Okay, exit, do right. Then I go to this router and advertise two networks 10, 10, 10, 10, 13. Enable config router EIGRP 10, then network of 10.10.10.0 255.255.255.0. hit enter. You see it also form adjacency with the other guy. So let's advertise another network, which was 13.0. This one. Exit, do right. So finally, let's go to this router and advertise all the three networks. Sorry. So I go to this router here, config router EIGRP 10 autonomous system number should be the same in the topology. Then we go ahead to issue a command network 10.10.10. No, it's 13 and 12. So the one is 13.0 255.255.255.0. You see it has form adjacency, reds. Then another one is 12. Good. It also form adjacency, exit, and do right. So all of these routers, they have exchanged information and then they are now aware of each other's status. So for example, if I can just go to this router and just say and show IP EIGRP, let me query neighbors. You see, there are two neighbors. There are two neighbors. The neighbors means this one and this one. So the neighbor of this guy is this one and this one. The neighbor of this guy here is this one and this one. The neighbor of this guy is this one and this one. The same applies to this router. It has two neighbors, this one and this one. As long as this router as its neighbors, automatically it will.
Ben, I have a question.
Yes.
Did you mean for router 2, it has only two neighbors or it is three?
It has two neighbors.
How about for this EIGRP, you don't consider the other side?
No. That's why I'm about to finish this statement. As long as this router 0 has this as its neighbor, it automatically knows the status of router 2, because router 2 has already shared the information with the router 1 here. So router 1 will share the same information to router 0. The same way, router 2 here will automatically know the status of router 2 because they share the same neighbor here. As long as the two routers share the same neighbor, they know the status of each other, because that neighbor is like the neighbor that gossips. Whenever it receives information from other router, it tells the other guy. Yeah, so it's something like that. It's as long as they share the same neighbor, they know the status of each other. So for example, even if I go to this router here, it has the two neighbors. They're directly connected, this one and this one, this one and this one. We only count neighbors in terms of routers, not the other side, only in terms of routers. And show IP EIGRP neighbor. You see, it also has two neighbors. And show IP EIGRP topology. Let me say topology. No, let me go to this router that was bringing a lot of confusion here. Show IP EIGRP topology, and you can see it has just the information about the neighbors. So as long as the two neighbors share one point of contact, they'll automatically know the status of each other. So maybe if I can just ping from this PC again to that one. So let me just wait and see. Destination was unreachable. What might be the problem? Okay, the first thing I'll do here, I'll try to ping the default gateway. Let me not use this one now. Ping 192.168.1.1. That's going. Now 10.10.10.10.10.10.1. That's going. Then 11.1. That's going. Then 13.1. 12.2 now. I want to ping 12.2. I want to troubleshoot where the problem is. That's going. 12.2. That's going. Then now 192.168.2.0. Did I really advertise it here? Oh, I did advertise one network. That's why we get the problem. You can see I didn't advertise this network on this router. I only did for only two networks. You can see here. I didn't advertise the third network. So let me just do it very fast. Router RIP network 192.168.2.0 255.255.255.0. I think I'm just confusing myself too much, because you can see I'm using RIP again, and I was supposed to use EIGRP.
Yeah.
So what I do, just say no router RIP to delete it. So use the correct command, router EIG.
Is that enough, or by you need to do like do reload?
Because it didn't have entries, so I don't need to reload it. As long as I've deleted it and it didn't have any entry, so I don't need to reload it. Yeah. So and again, now advertise this network, that one, exit, and do right. So I'll go to this router again, this PC, and ping the destination that refused to connect. That destination was refusing to connect, so I'll try to ping it again and see. So you can see it's now reaching. I was just a little bit confused. So if I go to this route again and type this information, so you can see 2.0 is here. Can you see it?
I see that.
Yeah, because they share the same neighbor. This neighbor gossips, tells each of these routers the status of the other neighbor. So for example, it tells router 2, oh, router 0 has this thing, do you have it? Router 2 say, I don't have it, keep it, or something like that. So even if I go to router 2 here and say show IP EIGRP topology, you will see 1.0 is here, and 1.0 is not connected to it directly. It's only that they share this one as the neighbor. Alright, so that's all about it. EIGRP is very simple how to configure it. You just have to make the router using EIGRP with the autonomous system number of a value of your liking. Then you advertise the directly connected networks. You check carefully that this router is only connected to two networks, this one and this one, and you advertise only those networks. For example, this router is connected to this network, and this network. You advertise only directly connected networks, and that's all about it. Maybe if you have question about EIGRP, so that I can explain it.
So departing from that, you will say that the router 2 is connected to 3 network, right?
Yes.
So that was my question. That was my initial question, because you were saying that the router 2 is connected to these 2 networks, but the one with the 1 and 2, 168 was like forgotten. So, but that means the router 2 has 3 neighbors, which is different from router 1, which has 2 neighbors, right?
Well, not that. If I can just go here again and say show IP EIGRP neighbor. My point is that each router here has only 2 neighbors, but router 0 and router 2 are connected using 3 networks, but they have 2 neighbors. We count neighbors in terms of routers.
We count neighbors in terms of
routers.
networks.
Not networks.
Routers, sorry.
So you see on the other side, there's no router on this side. So it cannot form neighbor on this side. It can only form neighbor.
So that means it has 2 neighbors, but 3 networks.
Yes. Yes, because you can see
gotcha.
router neighbors are only formed between routers, not between a router and a switch. So it's only between this one and this one. So they are neighbors between this one and this one. Yeah. So do you have any question?
I'm okay with that. So
right.
We may close the day, and you will send me the video. I'll be check it out, and maybe probably the assignment. But I've been working I've been working on the other assignment. I couldn't get time for this week, but I will try to end up by the end of the weekend.
This is the most interesting part of routing, because it's very, very easy to configure. Few commands, easy understanding. So let's move to OSPF. So if you want to move to OSPF, you just go to each of the routers, and we just.
And how long it's gonna be taking
to configure OSPF? Around 10 minutes. Are you?
Okay.
Yeah.
Okay. Okay. Go ahead.
Yeah. So let's just do it very, very fast, or we can just postpone it to another class if you have this.
No, if it's taking 10 minutes, I will be okay with that.
Okay, config T, and just say no router EIGRP 10. Remember the first thing we are doing, we are configuring router EIGRP10. So we're just telling the router, delete it. And we hit enter, copy, and do right. We don't even need to reload. That's just enough. I just go here also, enable, config, and I paste that command. I do right. You don't need to reload, it's just enough. I go to this router again and config, I paste it and do right. That's just enough. Finally, I go to this router and config, I paste it and do right. Okay, so that's enough. So let's start configuring the OSPF. The explanation is the same. It's just few commands that are just different. So I'll go to this router and start configuring OSPF, just like the previous configuring or configuration. We just make the router aware that it's using OSPF as the routing protocol. And now there's a concept that we did discuss under our note. It's called process ID. It's just like autonomous system number in not actually, but a process ID in OSPF. You will understand it better. But as for now, let's just configure it. Let's say it uses a process ID of 20, and then let's now advertise networks. So router 0 advertise network 1 and 2 168.1.0. Then subnet mask 255.255.255.0. Then now this is where we put area. Area we said is like autonomous system number in EIGRP. We just say area 0. Let's use area 0.
And you choose the area randomly.
But strictly always use area 0 because area 0 is the foundation, the backbone. We normally call it backbone area. So in every topology there must be a backbone area.
And another question: the OSPF number, the 20 you choose is you need to choose different number with the grouping number, like the 20.
No.
It needs to be different from the one they use for EIGRP 10.
It doesn't necessarily mean that it should be different. You can choose any random number, but make sure that in all the router, this number and this area should be the same.
It's the same.
Yeah.
Oh,
so you just hit enter, and now you go to another network. 10, 10, 10. Then another one is 11, 11, exit, do right. Then I go to the other router and advertise this to one. I do it very, very fast because now these are just repetition. You can see they have formed adjacency with the other router. So let's go to this router also. I do it very fast to save time. Then finally I go to this router also. Okay, so I've configured OSPF, very simple, just like the previous configuration. You can see just similar, they're very similar just for few commands that are different, but just the configuration is just the same. So if you can just go to any router and just say do show or do show IP OSPF neighbor. You can see they only have 2 neighbors. Each router has 2 neighbors because you can see each router is connected to 2 routers. So it should have 2 neighbors. But if we just say do show OSPF database, you will see we have 10, 12, I can't see 2. Okay, it's here, sorry. All the networks are here. If you say do show OSPF database, you can see 10.1.0, 2. something, 10, 11, 10, 12, 13. So this PC should be able to communicate with other PCs on the right. So if I can just try to ping, oh, destination host unreachable. What's the problem? Did I advertise one? Troubleshoot. Were you going somewhere? Hello?
Sorry.
Were you going somewhere?
Yeah, we have a meeting.
Oh, sorry. But this is how to
but that's okay. That's okay.
yeah, because
Yeah.
this is the right way to configure SPF. But in the next class, you should join much on SPF because it's one of the
Yeah, I think for the next class we can start from the end.
Yeah,
and,
OSPF.
I will be okay with that. And yeah, for OSPF. But so far I got for our rape and
EIGRP.
the EIGRP.
Yes.
That was good. And
Okay, no problem, bro. Just
we can.
just have your meeting. Let's meet again. I'm going to prepare this video and send to you later.
Yeah, okay.
Bye.
I appreciate it.
Bye.